So this video gives you an overview of what an operating system is. Again, many of you have most likely used operating systems without even realizing it. Most likely, if you're watching this video on a laptop or a desktop or a mobile phone or an iPad, right? So most likely, most of the computing systems that we use today have an operating system. We just don't realize it very often, right? For example, look at it. If you're using a laptop or a desktop, most likely if you're using a Windows operating system, some Windows-based operating system, or some of you may be using a Macintosh or a Mac operating system, right? If you're using a Mac, right? An Apple laptop or Apple desktop, or some of you who are more hacky, who are more interested in, who are more hackerish and who are more interested in fundamentals of computing. Some of you may use some distribution of Linux, right? So again, all these are operating systems that you have used on desktops and laptops even without realizing it, right? Very often, more important than these, Android is one of the most popular operating systems in the world. And at the core of Android itself, at the very core of Android itself, there is again, we'll discuss about more details. At the core of Android itself is a Unix kernel, right? Again, Android itself is built on some of the concepts of Unix. Again, today we don't use Unix as much directly. It's one of the earliest and very, very popular operating system. Again, your Mac and your Linux have been inspired heavily by Unix, right? At the core of Mac is actually a Unix-like system. At the core of Linux is an open source variation of Unix, right? So Android itself contains at its very core, often called the kernel, right? Kernel in English. Kernel basically in English means core, at the core of something, right? At the center of something. So at the center of Android, you have a Linux or a Unix-based kernel or a Unix-based system at the very core. Similarly, if you are using an iPhone, you have an iOS, or if you're using an iPad, right, you have iOS. All these are operating systems that we interact with on a day-to-day basis extensively. So in this course, I'll keep giving you examples from Windows and Android, two of the most popular operating systems that many of you may have used. Again, I'll also give you examples from Mac because I'm recording this on a Mac, right? So I'll keep giving you examples. I'll keep giving you intuition on how a specific concept we are learning is applied or is used in a popular operating system that we all use, right? So to the best of my knowledge, operating system is often the most used piece of software, which we all use. How many of you use an Android phone or an iOS phone, right? Almost over 99% of phones or smartphones in the world today are either driven by Android or iOS, right? Most of the laptops, desktops are either driven by Windows, Mac. Most of the servers at some of the largest companies are mostly powered by Linux, right? Of course, there are more operating systems than just these, but these are some of the most widely used operating systems in the world, right? So I'll keep giving you examples from all of these domains, from all of these. Again, each of these operating systems have their own advantages, disadvantages. I'll keep giving you examples. When we learn a concept, I'll give an example from Android or Windows or Mac or Linux, etc. Right? Operating system is extremely important for a software engineer to learn about because we end up using operating system a lot of times without even realizing it. Okay, let me give you a simple example. Suppose if you're trying to write something to a file in a C programming language, you might use things like this, right? You might use fprintf or fopen. How do these functions actually work internally? How do these functions eventually write something to a file? Even when you use simple things like printf in C programming language or scanf, printf prints something to the monitor, right? How does when you write printf, what actually happens internally, right? How does this printf eventually end up printing something to your monitor? Similarly, when you write scanf, you get some input from the keyboard. How does that actually happen? How does that exactly happen? All of these are actually internally powered by the operating system itself, right? So there are lots of things that we have learned of either in C programming in many places, without even realizing that a functionality like this was impossible without the operating system, without modern operating systems, right? So what we learn in operating system is a very, very important key piece of software that we as software engineers would end up using extensively throughout our careers, right? So I'll give you practical implications and practical concepts wherever required and wherever it is needed. But I'll also explain you the foundational concepts of operating systems that will stay with you all your life as a software engineer, right? Now your question might be, okay, all that is good. What does an operating system do at its very core? Right? What does it do? There are multiple things an operating system does, and no definition is complete. At its very core, an operating system can be thought of as a resource manager. Now your obvious question is, what is a resource? What is a resource? You're saying it manages something, right? But what is a resource now? Look at this. Again, I'm giving you some high level overview. I will go into the details as we go forward, right? So here is your CPU. Your CPU itself has multiple pieces. Your CPU itself might have, let's say, okay, let me erase this. Your CPU itself has a control unit and an arithmetic logic unit and some registers and things like that, right? This is your CPU. This is your main memory or RAM. Your CPU reads data from your RAM effectively. Now your CPU also takes inputs from your keyboard and executes some things. Again, your CPU doesn't directly take input from your keyboard. All of that information goes via the RAM. So this diagram is at a very high level block diagram. The more details of it we will learn step by step. Okay. Your computer itself takes inputs from a mouse. If you're using an Android like operating system, there are inputs that it takes from a touch based interface. When you touch on your Android phone, you're giving some input to the computer, to the CPU to act on. Similarly, you write things to your monitor, right? Whether you print something to your monitor or whether you show some graphics on your monitor, you can give commands to a printer to print something, right? So similarly, when you're watching this video, you're transmitting data via your LAN connection or Wi-Fi connection, right? Similarly, if you want to talk to your disk, here your disk can be your hard disk. Look at this. Your disk could mean hard disk, your solid state drive, your pen drive, right? All of these are often referred to as secondary storage devices where you can store data permanently. Again, your CPU does not talk to these things directly. Your CPU talks to all of these things via the RAM. Okay, but I'm just giving you a high level overview here. All of these are often referred to as hardware resources. Your resources themselves come in two shapes. Again, we'll learn a lot about resources. Your resources could be hardware resources. Your resources could be software resources. Hardware resources are things like your keyboard, mouse, touch, monitor, your printers, your LAN or Wi-Fi, your hard disks, right? Even your RAM is a hardware resource, right? That your computer needs to manage, right? Even your CPU is a resource. Your CPU itself is a resource. Your CPU here is a resource that the operating system manages. Again, you might wonder, can we live without an operating system? Yes, it is possible. The early stage of computers did not have proper operating systems, but operating systems enabled programmers to build much more efficient systems. Okay, we'll come to that. We'll come to those aspects in one of the next videos, right? So at its very core, an operating system is a resource manager, but it's not just a resource manager. It also helps software developers. It eases the life of a user, the convenience. It simplifies, it provides convenience to the users of the operating system. It makes your life extremely simple, right? And at the same time, it also makes the life of software engineers who write code, it makes their life easier. For example, let me give you a simple example. If you're a software engineer writing some code, right? You just write printf and scanf, and how it works, you don't have to worry about, right? If you write some program with printf and scanf, right? With some C program, and if you compile it, let's say on a Windows box, how does Windows enable this printf to show something on the monitor is something that the software engineer need not worry about much, right? Because that's something that is taken care by the operating system for you, right? The same code, the same snippet of code, I could take it to a Linux box or a Mac, or even in some instances to Android, because I can write Android code in C, C++, right? I would just compile it let's say I compile it on a Mac, and it executes and it still shows something on the monitor. How it works is something that a software engineer need not worry about. So an operating system provides a bunch of functionality for the software engineer so that everything works. Imagine a world where there is no operating system and where every software engineer has to implement how to talk to a monitor or how to get an input from a keyboard or how to write something to a file. Imagine if you were to implement how fopen, fprintf, printf, scanf works internally. That would become extremely cumbersome. That would slow down writing software enormously, right? So operating system gives us a bunch of functionality, a bunch of utilities. Okay. So it's a resource manager. It gives us a bunch of utilities. It gives us a bunch of utilities and some to simplify software engineering, to simplify, more important, to simplify writing code. Even if you're not a software engineer, if you're just using an operating system, imagine if I'm just using my laptop, which has, let's say, a Windows operating system. If I'm just using it to, let's say, browse the internet, right? My web browser like Chrome or Firefox, these are pieces of software which run on your operating system, right? So your browser uses a lot of functionality that the operating system provides because your operating system helps the browser connect to your LAN or Wi-Fi interfaces, right? So a lot of software that we use depend on the functionality that is provided by the operating system to help you use these things. Or in other words, imagine a very simple application. If you want to search for a file on your laptop or on your Android phone, how do you do it? Right? Depending on whether you're using Windows, Mac or Linux, there is some utility where you can just go and say, I want to find if this file exists, right? That such a file searching utility is provided by the operating system because the operating system talks to the hard disks or solid state drives or pen drives that you have as part. Your operating system talks to all these permanent storage devices, right? Because your operating system can manage all of these resources and it manages all of these resources. It can provide you utilities and it simplifies the life of both end users and software engineers, right? That's what, again, this definition is not complete. An operating system does tons of things based on the context. Again, we'll discuss each of these things at its core level. But at the very core, it's a resource manager and it gives us convenience of usage. Okay, it makes our life much more simple by again, what is an operating system? An operating system at its core is a piece of software. An operating system at its very core is a piece of software. What is a Linux? A Linux is basically a bunch of lines of C code and assembly level code. Most operating systems are implemented in a low level language, or I should say most operating systems are implemented in C or C++. Most of them. Of course, there is some assembly level code also. That some of the pieces of operating systems are written in, because C and C++ again are very, very powerful when you have to interface with hardware devices, right? When you have to talk to hardware devices, C++ are like gold, right? So that's why most operating systems are nothing but pieces of software written in C++. Okay. So again, these are some of the things that an operating system does. Now, in this course, we'll learn about a bunch of concepts. Okay, I'm just giving an overview of all the concepts and which concepts are more interesting and important, where we'll dive deep into. Okay, the first concept is called as process management. Again, many of you may not know what a process is, but we'll discuss what a process is in lots of detail. Don't worry about it. But we all encounter programs, right? We all encounter programs. Oftentimes, a program is broken down into multiple processes, right? A program gets broken down into multiple processes. And let me show you an example here, right? So let me show you. This is called an activity monitor. Okay, this is what is called as an activity monitor on, okay, so let me show you this. This is often called as an activity monitor on a Mac. I'm recording this on a Mac. You have something similar to this, which is called the task manager on Windows, right? Look at this. If I just go to this, this is all the list of processors. Sorry, this is a list of all processes that are executing on my system now. I have a screen recorder, I have activity monitor, I have PowerPoint, I have Camtasia, I have all these are processes that are running. Each process uses some CPU resources. It has been running for some time. It has a bunch of threads. We'll learn about what threads are a little while later. Okay. Again, it tells me how much memory is each of these. Memory basically here corresponds to RAM. How much RAM is each of the processes are using? How much energy are they using? How much disk space are they using? How much network in terms of traffic from the internet they're using, right? So all these are different processes that are being managed by my operating system. Again, Activity Monitor is a utility that is provided by the Macintosh or the Mac operating system to help me understand what all are running. Again, in Windows, if you press Control Alt Delete, you get a task manager wherein you can kill a task or wherein you can kill a process. Like for example, if I want to kill a process here, I can just go there, and if I press on this cross, force a process to quit, I can make it quit. I don't want to quit it now. I don't want my computer to crash now, or I don't want to kill anything while I'm recording, right? But this is the list of processes, right? Again, for every operating system, there are a bunch of processes, and what a process is, given any program that you're executing, a program gets broken down into multiple processes. Okay. Again, we'll understand this in lots of detail. There is a whole chapter called process management, one of the big chunks in operating system, wherein we learn about how your programs. Imagine if I have a program, how does that get executed? Okay. So we'll learn about all of them. So within this, there are a bunch of concepts. Again, if you don't understand these terms, please don't worry about it. There is a concept called scheduling. Again, we'll touch each of these topics. Amongst all these topics, we'll spend a lot of time on inter-process communication and synchronization. Again, process management is a very, very important technique even for a software engineer, right? Because if you're writing programs, remember, we all write programs. Understanding how this program gets executed by the operating system, or how this program gets broken down into processes, and how each of these processes gets executed on the computer. This is very important because this enables you to write much more efficient and well-engineered pieces of software. Again, this is something that I have used in my own professional experience a lot of times. Again, we will focus on all these concepts, but we'll specifically focus on inter-process communication and synchronization to a lot more detail. Very interesting topic, but there's a whole chapter called process management where we'll go into all of these details. Okay. So the next thing is called memory management. Memory here, we are talking about your RAM, your main memory, often referred to, your RAM is what is often referred to as main memory. Now again, RAM is a very, very important resource in your whole computer, right? So we'll learn about how the RAM itself is organized. What are the techniques to manage the RAM? And the most important topic here is something called as virtual memory. Terrific concept. Very, very ingenious concept. So we'll spend a lot of time on how virtual memory itself works. Why do we need virtual memory? And how does this enable, how is this critical for modern computers? Okay. So memory is, again, remember, each of this is a resource. At the end of the day, I told you that OS is a resource manager. Process management is all about managing your CPU, because your CPU is where all of these processes or programs get executed. So process management is all about CPU management, right? Your memory management is all about memory. Memory or RAM is one of the most important resources, right? So here again, a bunch of techniques we'll go into. We'll learn about some hardware specifics, right? We'll learn a lot of, but especially virtual memory is a super duper interesting concept here. The next thing is obviously file systems. Okay. At the end of the day, if you're storing your data on a hard disk drive or a solid state drive or a pen drive, right? Everything needs to have a file system on which everything gets stored, right? So here we'll learn about what is the interface to a file system, and this is the very important topic. How is a file system implemented in the first place? How do we implement a file system? Similarly, just like file system, again, files basically correspond to your secondary storage devices, like your hard disks, solid state drives, and pen drives, where you're storing data permanently. Similarly, there is a concept of device management. Again, these devices could be other devices. For example, your keyboard, right? Your other devices like your keyboard, like your printers, right? Like your monitors, right? How do we manage all of them? So we learn a bunch of concepts on how all of these systems are managed, and equally importantly, how some of these things are implemented in modern operating systems. Very important concept. Next, finally, we will touch upon ideas of security, how to ensure that people don't hack into your system. How do we design, how do passwords work? How do user accounts work? And how do we avoid, especially in security and protection mechanisms, we learn how to avoid, how viruses are built, right? How malicious software like viruses or malware, right? How some of these things are designed, and how do you make your systems safe from these? Okay. So for most of this course, we've used very standard textbooks that are used for at most universities. These are the books that I have personally used. So Operating Systems by Galvin, a seminal book, terrific book going into lots of details. There is also a book called Operating Systems by William Stallings. Very good book again. Lots of nice examples. There's also a book called Modern Operating Systems by Tenenbaum, a terrific writer who has tons of books both on computer networks, on operating systems, lots of topics, right? So these are the three books that we have referred to. Again, in addition to all of these three books, we've also referred to documentation on how Linux works internally, how Android works internally, right? How Windows works internally. So we've also taken lots of pointers from practical aspects of some of these very popular operating systems, and we'll touch upon them as and when we encounter some concepts, right? So very, 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 very interesting and exciting subject ahead of us. And I hope you got a good sense of what's happening what lies ahead of us, right? So this is what an operating system does. And again, for a software engineer, understanding how an operating system works is extremely critical. It's extremely important, because you as a software engineer would often use a lot of functionality and utilities that an operating system provides. Again, in addition to convenience, an operating system also wants efficiency. Let's not forget that fact. And an operating system wants to use all of the resources that you have very efficiently. Okay. So I talked about resources which are hardware. There are also something called as software resources. Again, we will touch upon what software resources are when we learn about this concept. There is no point for me to just throw some terms at you. Okay. But if you want it, so there are a bunch of software resources also that like for example, you have something called as pipes, right? You have things called as semaphores, right? You have things like signals, monitors, right? All these are software resources that are also managed by the operating system. Again, you may not know what these are, but we'll touch upon them when the context arises. Okay. So at the end of the day, in addition to convenience, an operating system also wants to efficiently use all of the resources that we have. Efficiency in addition to convenience is what an operating system is trying to enable at the end of the day.